All right, 8.2, transformations of logarithmic functions. So here, what we're going to be doing is we're looking at the transformations, so the graphs of logarithmic functions. A logarithmic function of the form f at x is equal to a log base of 10 times k x minus d plus c can be graphed by applying the appropriate transformations to the parent function. So, here are the original functions, and don't forget that log base 10 of x can be written as log of x. It's assumed that if you write log of x, that the base that we're looking at is 10. An example of where we do this is basically the value of x. X has a power of 1. We don't write the 1, but x itself, we know there is 1x there. Another example is square root. We do not write the little 2 inside a square root sign, but we know it's there because we call it a square root. Meantime, back to here. So what we're doing here is plugging in values for x. Now remember, log base 10 of x means that we're dealing with base 10 information. So I'm starting with 1 over 100, which is 10 to the power of negative 2. When you take log base 10 of 10 to the negative 2, you're going to have a value of negative 2. Because what this is saying is 10 to the power of something gives us 1 over 100. That something is negative 2. Do the same for the next one. 1/10 is equal to negative 1. 1/10 is, for x, is going to be negative 1 for the y. And again, we have 1, 0, 10, 1, 100, 2. And when you apply the transformations, you apply the transformations exactly as we've done in the previous units, the exact same way with k and d. And you have to apply the transformations. Remember that the descriptions remain the same as before for all functions. Be careful of the asymptote. That's probably the most important piece, is the particular asymptote in a logarithmic function. Now, example, the function f at x equals log base 10 of x has the point 10, 1 on its graph. If f at x is vertically stretched by a factor of 2, reflected on the y-axis, horizontally compressed by a factor of 1/2, horizontally translated 3 to the left, and vertically translated 2 units down, you're asked to determine the equation of the transformed function, and part B, determine the coordinates of the image point, and finally part C, determine the domain and range. So let's look at the first part. Let's find the equation of the transformed function. To do that, we set it up. F at x, how do we know it's f at x? Because you're given that. You're also told it's log base 10. So we know that all of these transformations have happened. So let's look at these slowly, one by one. All of the ones that are in yellow right now involve something vertically that happened. So vertically stretched by a factor of 2. Vertically translated 2 down. Why is nothing else involved? Well, those are the horizontal transformations. So when we plug this all in, vertically stretched, there's your 2. Vertically translated 2 down. You're going to have a minus 2 at the end. Okay, so 1 second, you have a minus 2 over here. Then you have log base of negative 2 bracket x plus 3. So what we have here is this negative 2 is horizontally compressed by a factor of 1/2. It's reflected in the y-axis, so that's how our negative 2 happens. And then we said translated left 3, so we had to put that in brackets in itself to indicate that there's a left 3 translation. Now, the coordinates of the image point, you basically take 10, 1, which is the point that they're talking about, and convert it according to this transformation. Well, that means that, okay, when we're looking at it, 2 times 1 minus 2, so the outsides will end up being 0, and the insides is negative 1/2 times x, left 3 is minus 3. So negative 1/2 is negative 5, and then minus 3 is going to give me negative 8. The domain and range, very simple. The asymptote changes so does the domain then. So x is going to be less than negative 3. The reason why is there's a reflection, so it reflects horizontally. And then what happens is that there is also a translation. So the translation is going to be from 0, we're going to move this whole function to the left 3, therefore that's where our new asymptote is going to be. The range is also going to be y belongs to real, so it's the same for both the original and the new function. So when the original, what we're talking about, this is originally what happens, and then the domain changes according to anything that affects the domain, which is the horizontal translation of 3 to the left. The horizontal compression will not be affected, but definitely the reflection in the y-axis could definitely affect our answers. All right. Anyways, bottom line is, in this section, we're looking at graphing. Can you graph given information? And hopefully, you learned from the previous units that this all makes sense and you're able to graph. All right then, have a good night, folks.